happening, how, and wanna know everything now. Oh yeah! How does this thing work? Why does that stuff change? How does that do what it just did?
Ugh, I'm so bored. Me too. Hey, wanna go illegally set off some fireworks in my backyard? Yeah.
Hey guys, this is wrong.
No, it'll be fun.
Hey! I just happened to overhear your conversation while I was sleeping in your closet. Can I help?
Well, they want to set off some fireworks, but it's dangerous.
Excuse me. I mean, I'll do it as long as I understand the science behind it. What?
Wait, guys, let's go downstairs while we explain it.
Now explain the science. Well, a small tube called an aerial shell contains explosive chemicals that cause the firework to be set off.
The aerial shell is made up of gunpowder and stars.
Wait, you mean like stars from the sky?
No, silly. The stars are small globs of explosive materials. Duh. They're what give the fireworks their beautiful colors. Did you know that when we watch fireworks, we are actually watching the explosion of stars?
Each jar contains 4 chemical ingredients, but you probably don't know what they are.
Actually, I do. There must be an oxidizing agent, a fuel, a metal-containing colorant, and a binder that holds everything together.
I know what an oxidizing agent is. It usually produces oxygen to support the combustion of fuel in a firework.
In the presence of a flame or a spark, the oxidizing agent and a fuel are involved in chemical reactions that create intense heat and gas. Oh yeah, and the metal colorant gives it its color.
Colors as in red, orange, yellow, blue, green, purple?
You're so dumb. If we're going to be technical, it's the electrons in the metal colorant that give it its color.
Electrons are negatively charged particles. Okay, the electrons absorb energy from the heat of explosions. We'll get to the explosions later, don't worry.
The electrons become excited. Unlike me, when I have to explain things over and over and over and over and over again to you.
Megan, easy.
Alright.
The excited electrons jump down to different energy levels in the atom. Different lights are given off when the electrons jump to different levels. Just like Miss Rose played it out for us in class with the bookshelf.
Oh my gosh, yeah, we already learned about that in class.
What about the shapes of the fireworks?
The shapes of the fireworks depend on the arrangement of the stars. If the stars are arranged randomly in the aerial shell, they will spread evenly in the sky after the shell explodes. And if stars are placed carefully in patterns, the firework has specific shapes, like a heart or a triangle.
Or like a parallelogram, eclipse, quadrilateral, rhombus, or trapezoid.
What? I don't even know what some of those are.
The explosion of a firework happens in 2 steps. First, the aerial shell is shot up into the air, and then it explodes. At the center of the shell is the bursting charge that we mentioned with a fuse on top. Igniting the fuse with a flame or a spark triggers the explosion of the bursting charge and of the entire aerial shell, which is why we light with a match or a gas lighter. The aerial shell is placed inside a tube called a mortar to propel it into the air. There is gunpowder in the mortar which explodes from a fast-acting fuse that is ignited with a flame.
So wait, let me get this right. The explosion of gunpowder probably creates lots of heat and gas, which would cause the pressure to build up, and when the pressure gets great enough, the aerial shell will shoot into the sky, right?
Obviously, do we have to spell it out for you?
So far, we've described how the firework gas gets up into the air. But a firework explodes in 2 different steps. The first step is when the aerial shell is shot into the air, which is what we already said. The second step is when the firework explodes in the air above the ground. That's the exciting part. When the aerial shell is shot up into the air, another fuse goes off inside the shell. It's called a time delay fuse.
By the look on your face, I can tell we're going to have to explain this one too.
Megan, lay off. I'll explain. We don't want you to explode like a firework.
Oh!
Okay. The second fuse causes a burst of charge to explode. This lights the gunpowder and stars in the shell, which produces lots of gas and heat. This makes the shell burst open, propelling the stars in all different directions.
Jordan, you forgot to talk about Charles's law.
I got this.
Wait, doesn't Charles's law state that when pressure in moles are constant and volume and temperature are the variables?
Mm-hmm. Yeah. The heat from the second fuse, which was the time delay fuse, increases the temperature. In order to maintain a constant pressure, the volume must increase. The volume keeps increasing and the gases expand until the aerial shell eventually bursts.
But what causes the loud boom we always hear? Is it caused by the heat?
No, actually, it's caused by something much more amazing than that. It's called the sonic boom. I didn't know that part. What causes a sonic boom?
A sonic boom occurs when an object travels faster than the speed of sound.
Now that I understand the science behind it, let's get ready to set up some fireworks!
Wow, those fireworks were so cray.
Totally.
Hey, Hunter.
Hi, I saw the fireworks last night. They were great. Hey, can you teach me the science about it?
Yeah, definitely.
Yeah, let's do it.
Not this again.